In this problem, we're asked to find the final velocity of the projectile just before it strikes the cliff. The main idea in this problem is vector components. To find the magnitude of the velocity, we'll find the x component and the y component, and then take the square root of the sum of their squares using the Pythagorean theorem. To find the direction of the velocity, we'll take the inverse tangent of vy divided by vx. To find the x velocity, we use the kinematic equation that we derived in part A, which says that the x velocity is always equal to its initial value. The initial value of the x velocity is equal to the x component of the velocity with which the projectile is fired, vm, minus the velocity of the cart. Plugging in numbers given in the problem statement, we find that vx is equal to 14.25 meters per second. To find the y velocity of the projectile, we use this kinematic equation derived in part A. For v0 y, we put in the y component of the velocity with which the projectile is fired. For y minus y0, we put in h, which is how high the cliff is. We substitute in the values given in the problem statement and evaluate to find that vy is equal to 0 meters per second, which means that the projectile is at the highest point in its trajectory when it reaches the cliff. Now that we know the x and y components of the velocity, we can solve for its magnitude and direction. Plugging in the two values that we just found, we see that the magnitude of velocity is equal to 14.25 meters per second, and its direction is 0 degrees. This means that the projectile is moving in a purely horizontal direction when it reaches the top of the cliff, and is at the highest point of its trajectory.